Today we will be talking about the SunRise building, which recently underwent an incredibly challenging revitalization project, a deep energy retrofit targeting 65% GHG emission reductions while rescuing an old dilapidated building and bringing much needed, sustainable, affordable housing units to the market. The case study will guide attendees through the project inception, decarbonization strategy and verification, financing requirements, and construction execution. Our speakers will also present outcomes in energy savings, GHG emission reductions, and embodied carbon results, demonstrating how these were achieved through energy and carbon modeling. So without further ado, I would like to introduce our speakers for this session. First is Audrina Lim, Director of Sustainable Construction at Chandos Construction. Audrina is an Australian and Canadian architect with over 20 years of professional experience. Her interest in ethical, sustainable development has empowered her to shift careers into the sustainability realm with Chandos Construction. Audrina's role as the Director of Sustainable Construction enables her to support Chandos to deliver lower carbon buildings, attain energy targets on buildings, research and develop climate resiliency strategies, and reduce Chandos' GHG emissions in operations. Through her experience as an architect and management professional, Audrina brings a multidisciplinary aspect to her role. She is excited to be collaborating with industry partners to build a healthy and resilient low-carbon construction sector. And next we have Neil Shannon, Executive Vice President at Avenue Living. Neil Shannon has 12 years of real estate asset and facility management experience and has overseen $350 million of capital improvements on residential and commercial properties. Mr. Shannon joined Avenue Living in 2009 when the organization owned under 200 residential units and supported the success and growth of the business from $20 million to over $6 billion in assets under management. Mr. Shannon has built and led new departments for Avenue Living, including the call center operations, IT and IS, procurement, and most recently, capital projects. Mr. Shannon obtained a Bachelor of Science in Mechanical Engineering from the University of Calgary and holds a P.Eng designation registered with APEGA. And last but not least, we have Dustin Tonsey, Project Manager at Chandos Construction. Dustin brings 11 years of construction experience across a variety of delivery methods and industry sectors. His strengths in adaptability, organization, and collaborative teamwork have made him a key contributor on several successful project teams. Dustin thrives in dynamic environments and consistently supports efficient project delivery through proactive coordination and strong communication. Dustin has been an incredible contributor to Chandos Construction with his curiosity, problem solving, and continuous improvement approaches in construction and project management. So everybody, please welcome Audrina, Neil, and Dustin.
Thank you for that introduction. That was great. Really awesome to see so many people here. The SunRise project is something we're quite proud of, and really happy to share more about our journey and how we pulled it off. I think for today, as we were building the presentation, one of the things we wanted to do is focus more on how we did it versus what we did. Some of the commentary we're hearing out in this space is there's a lot of people talking about deep energy retrofit. There's very few doing it. So now that we have one under our belt, we're going to get into some of the weeds on what went well, what didn't, what the challenges were, and how we're going to try and do more of it. So a little bit about Avenue. So we're actually at $8.5 billion worth of assets now. Our group of companies manages 4 different funds. One's multifamily. We just crossed over 22,000 doors. Our storage business has just over 10 million square feet of self-storage in Canada and the United States. We also have 50,000 acres of farmland, which most people don't know about us, and we have about 500,000 square feet of commercial property. So we'll get right into it. So for the agenda, we've broken it down to 4 parts. I'm going to give some perspective from the owner side on the project and the challenges that we faced. We're going to have Dustin take us through the construction process. as mentioned, it was a complicated project. There are lots of challenges and hurdles, and we're gonna talk about those and hopefully share some of the learnings from what we experienced. And Audrina is going to take us through some of the embedded carbon impact of the building, and we're going to hopefully leave about 50 minutes for questions too. So, yeah, that's our plan for today. So, I guess a little overview of the project. It was originally 1970s construction. One of the important factors of this building was almost all the building systems were original. Had very little investment or improvement over the 55 years that it was existing. So we'll talk a bit more about why that's important, but that's a big factor in how we selected the property. In terms of savings through the project, the GHG reduction, we're targeting 64%. Got to meet David here, who actually did our energy modeling. It's the first time we've met in person, so we kicked this off about 2 years ago, and glad he can see the finished product and what we're doing here. One of the probably coolest parts of the project was the solar integrated mural. So the entire building is wrapped with BIPV, it's solar integrated cladding. And on the north face, we partnered with a local Edmonton artist, Lance Cardinal, and we took a, I don't know, probably 2-foot piece of artwork and scaled it up to 85 feet. It set a world record. My kids think that's pretty cool. And what else can I tell you? Did want to talk a bit about Avenue's other deep energy retrofits. So SunRise is one of many. We have 2 other streams of work that are underway at various stages. So one of them, we have a partnership with the Canadian Infrastructure Bank. So that's a $150 million commitment to improve our buildings. We've broken it into 3 equal phases. Phase 1, we're about 70% through. And then phase 2 and 3, we're working with Chandos on pre-construction. So we're in planning stage there. We also have 2 towers in Calgary that we hope to do something similar with. They'll be sister buildings to SunRise here in Calgary. So this is one of many. I think some of the lessons we hope to share are from things we've learned with SunRise and also our other initiatives. So I'll keep rolling. So again, biggest question is how we pull this off. I'm going to talk about program creation on another slide, but generally speaking, at initial stages, you're going to want to know how you're going to fund the work. So whether it's grants, initiatives, financing, having an awareness of what your options are and what you might be selecting is going to dictate how your process is laid out. The next big thing for us was identifying which buildings are the best candidates. So at Avenue, we have, I think, over 800 properties. So to understand which were most suitable for retrofit, we fired up an energy management team. So we now have 2 people who are focused solely on energy and conservation. And they did a massive analysis on our utility consumption. They normalized it so we could rank one building to another. And our program is built around taking the worst offenders for consumption and starting with the buildings that are going to have the biggest impact through this work. Once we have our list of properties that we want to target, we go and complete energy audits. So lots of different providers out there. The energy audit is going to give you a menu of what we call energy conservation measures, or ECMs. And we go through a process to review which are most suitable for the property, and we'll get to a final list of ECMs to move the project forward. At that stage, it's usually when we're calling a GC like Chandos. What we find with energy audits is the savings are usually pretty dialed, but one of the lessons is the cost estimating isn't as accurate as what we would get from construction companies. So getting good data and estimates on your construction early is very helpful in some of the decision-making that comes next. After that, depending on your financing source, you're probably going to have requirements for additional certification. So, for example, with our CIB program, we need IREE certification on our projects. So you're going to take the energy audits and your business case and cost estimates and go to probably CAGBC and try and get your project certified. It'll be typically a requirement for any deep energy retrofit financing. On SunRise, we partnered with BMO, who has their own program. BMO had a different requirement on top of IREE cert, so we had a requirement for what's called ISO 50001. It's an energy management standard. Our internal energy management team, they implemented the standard in our business, so we're now ISO 50001 ready, which is what we needed to progress with our loan with BMO. And lastly, the financing element. At this stage, you're probably narrowing down which path you're going to take and which options you're going to go with. So that's kind of the view of a single building process and some of our wordings along the way. One thing I wanted to add on building identification. So we've had some learnings there, and what we found is we want to target our largest properties from a physical perspective. We also want to target properties in our largest markets. So Calgary and Edmonton for us are our biggest centers. We had less success with looking at smaller buildings. The construction costs just don't scale properly to our smaller properties. So that was a big lesson that we learned from our phase one. So next couple slides here are a list of all of our ECMs, and they're sorted by the cost on this one versus the bar is the cost, and then the line is our CO2 reduction. We're going to share these. I'm not going to go through them all. It's pretty dry. Again, highlights for me were the solar BIPV, probably one of the most expensive ECMs. It's also the highest saver, dollar-wise. And also, we did a major change on how the building's heated and cooled. So we introduced in-suite heat pumps. So they're the water source electric heat pumps. And we switched our heating plant to a high-efficiency condensing unit. So those are probably the two highlights that I'd share. Again, I think we distribute these slides, so you're going to get copies of all this. So I won't dive into too much detail on what we're doing here. So next challenge that we face is around decision making. So we're living this in real time with phase 2 and 3 of our CIB program. What we do, so we're looking at probably 40 different properties. They each have an energy audit completed. Each property has a list of ECMs that we can select from. It's more or less a menu. Now we're in the optimization stage, so we're trying to figure out which ECMs by property and which buildings as a whole to include in the program. It's harder than we expected, so it's really balancing GHG reduction and construction costs is it's two items in tension. Next challenge that we face is investment modeling. So I'm not sure if people have had projects axed because there isn't a return created or enough savings, or it's a challenge for us. When we first look at the savings, if you take your utility savings and the cost of construction, generally that simple payback, it's just not interesting. it's not enough to get a yes on the project. So what we're doing at Avenue, we go several layers deeper to find other benefits that are both tangible and intangible to try and get these business cases over the line. So other things that we've included, I'd say a year ago when we were doing phase 1 business cases, we had carbon tax credits. They formed about a third of our savings. That's no longer available. So our job's a little harder, so there's more headwinds that we're facing to justify the work. We have something called an interest rate differential. So what we mean by this is because we've selected buildings that need retrofit, they need improvements, most of the building systems are end of life, we're going to incur a cost with our cash to do those improvements. A lot of the financing that comes with deep energy retrofit programs have very favorable interest rates, and that difference in our cost of capital versus a low interest rate is a way we can save some money doing work we're going to do anyway. So we factor that into our models. We're starting to look at repair and maintenance savings. Maintenance is usually pretty steady, but if we've updated an entire building, there's usually a honeymoon period where we're not doing repairs for, call it 5 or 10 years. If we improve an entire building, we can often raise the revenue, either increase rent or naturally through lower vacancy. So those are factors that we'd include. Calling this cap rate compression, so if people are familiar with apartment valuations, if we have a new building versus an old building, we can generally get a lower cap rate, which means the building's gonna be worth more. So that's an area where we can create some additional value and hopefully a slightly higher return. And then there's a lot of non-tangible work. So resident comfort is important. At SunRise, we added air conditioning into the building. So the building didn't have any cooling before. With the heat pumps, we were able to make it a more comfortable space. Not sure how to measure that in true value, but it's a benefit. Corporately, we also have ESG goals. So this program as a whole really helps us demonstrate our commitment to ESG. And then we get a ton of marketing value out of the projects as well. So that's a little bit about investment modeling, some of the challenges, and how we're getting creative to build those business cases. Internal approval, for us it's straightforward. We have an investment committee, but knowing your approval path, that's I would say it's very important to understand. And then at this point, you'd probably be nailing down your financing and getting term sheets and signing credit agreements. Also getting grants if you're able to. And this is my last slide, and we'll get it over to Dustin next. We've also built a program around this. So we talked a bit about individual process for an individual building, but our program has some key components. One's due diligence, so we do energy audits on the properties. We also look at other things like hazardous materials. So we'll do assessments early on what asbestos or mold we might be encountering. We'll look at environmental site assessments, building condition assessments as well. So we do a lot of front-end work. We've built a team around this internally. So we have what we call a steering committee for our CAB program. It's multidisciplinary. We have asset management involved, marketing, our operations team. We come together every 2 weeks or so and discuss progress, challenges. Most of our future projects are also in occupied buildings. So another logistical challenge, I say, for construction. So a lot of communication between our marketing team, our ops teams, and our residents. And lastly, the stage you're probably going to start selecting either equipment or contractors. I think probably one of the more important stages is you get projects approved and moving into execution. I'll plug Chandos here. They're a great partner for us in this space. These projects, as you'll love to see, they're complicated. They're merging old and new lots of building code issues, lots of unforeseen problems behind walls. So picking a partner that you're comfortable solving problems with, having hard conversations with is important. So I'm happy to report we're extending the relationship into phase 2 and 3 of our CIB program with Chandos. So that's really a bit of insight into our world and how we're overcoming some of the internal challenges around getting a deep energy retrofit completed. So with that, I'll bring Dustin in. He'll walk us through some of the construction problems.
Awesome. There we go. So with retrofits, the most broad and significant challenge is always dealing with a mix of new and existing conditions. In the case of the SunRise, a few of the more significant challenges included rusted and failing wall systems. So if you look at the photo on the left there, it shows the second floor exterior wall being braced back to the concrete slab after the existing stucco facade had started to delaminate from the existing rusted studs. There's existing asbestos and mold, so the original project intent had us only remediating the mold for the contaminated drywall and leaving the majority of the existing asbestos containing drywall in place. We experienced various delays due to additional mold encountered, uncommon door and closet sizes, routing of mechanical electrical penetrations, and suite submetering panels being added or resized due to existing sizes being discontinued. So multiply the above roadblocks by 179 suites, and each item has a very significant impact. Ultimately, a change order was issued to remediate all the drywall, including full replacement of the east and west exterior walls, which were far too rusted to support the BIPV system. As well, the existing asbestos stipple ceilings were another challenge. Any attachment had to be coordinated with abatement contractors, with either texture being grinded off or hangers installed by the abatement contractors. Project delivery. So for this project, we utilized a CCDC 5B construction management contract. With this delivery method, it allowed for early contractor involvement via pre-construction services. Chandos was able to provide site investigations, value engineering, constructability reviews, and mitigate risks. As well, we were able to onboard design assist mechanical electrical contractors, which allowed us to procure long lead time items such as the makeup air unit, boilers, and start the queue for the MDP retrofit, which was a 10-month lead time. This delivery model provided cost transparency and flexibility for the owner. Chandos, as the CM, worked alongside the architect and consultants and the owner, Avenue Living, as collaborative partners. This promoted a team-first culture where everyone was working towards the same budget, schedule, and quality goals. Envelope commissioning. So with that previously mentioned 64% greenhouse gas reductions, these final reductions are measured based on the final building usage post-construction. However, to validate some of the energy conservation methods that were implemented, we provided air infiltration testing. The targeted air tightness was 1.5 liters per second meters squared at 75 pascals. We boastingly achieved 0.95 liters per second meters squared. Yeah. We also facilitated water penetration testing in accordance with ASTM 1105 standards, and we exceeded the 290 Pascal requirement and passed testing up to 360 Pascals. Successes. So with this project being the first BIPV project in Western Canada, that's a success in itself. We're solidified as part of the Edmonton skyline. As well, it's crucial to mention that this wouldn't have been possible without the high level of communication, collaboration between Chandos, Avenue Living, consultants, and subtrades. We successfully navigated 336 RFIs and 217 approved change orders over 14 months. Through the process, we developed a strong owner-contractor relationship that was built on communication, transparency, and trust. Lastly, the project was nominated for and won the Chandos prestigious DBO Award, which recognizes outstanding project teams that reflect the vision of Chandos co-founder Daniel B. O'Brien, which focuses on operational excellence, inclusivity, collaboration, innovation, and courage. Truly a testament to the project's success. Lessons learned. So this is a bit of a bigger one. Pre-construction's worth it. On the SunRise project, Chandos facilitated over $2 million in value engineering over the 4-month pre-construction process. Avenue Living saw firsthand the benefits of early contractor involvement and has onboarded Chandos in the very early design and validation stages, working in a modified CM contract for phases 2 and 3 of Avenue's deep energy retrofit portfolio. That's looking to target approximately 40 to 42% GHG reductions over 38 buildings between Edmonton, Calgary, Camrose, and Lethbridge. Early contractor involvement allows for thorough site investigations to validate the feasibility and constructability of these conditions. When it comes to site investigations, more the better. Some of the key items that we captured here at the SunRise and that we're looking to keep in mind moving forward are thorough hazardous materials investigations, performing concrete scanning of slabs and core samples to determine the strength and composition of slabs where necessary, deconstructive testing, so open up walls, cut into roofs, really get to understand the condition of the building that you can't see from the outside, completing mock-up installations where appropriate to validate the installation methods and again, those existing conditions that come with a old retrofit building, reviewing, validating, and making changes to the design. So here at the SunRise, with this being the first BIPV project in Western Canada and an existing building retrofit, there was a high level of coordination that went into changing and validating the design for the structural attachment of the cladding system itself. Through the process, we ended up hiring a third-party forensic engineer for peer review and validation of the engineer's solution. Continuing on, mitigating hazardous materials. So the original project intent had that 4 feet of mold contaminated drywall removed throughout the tower with the remainder of the existing asbestos drywall to remain in place. Upon starting construction, we ran into considerable schedule impacts as previously mentioned. In the case of the SunRise, it was far more beneficial to schedule and cost to perform a total abatement rather than try and salvage portions. Dimensional challenges. One of the most significant challenges we navigated on site was that the BIPV cladding scope needed to be pre-manufactured with significant lead time. To do this, we had to coordinate and provide guaranteed measurements and dimensions for the panels to be fabricated to. HRV vents and windows had to maintain a 1/4 inch tolerance from the 12th floor down to the 3rd floor. Layouts were verified, double, triple, and quadruple checked to ensure accuracy. Last one, contingency versus risk register. Rather than carrying a certain percentage of the project value for contingency, Chandos and Avenue Living worked together to create a risk register which described all the possible risks that our teams could dream up. We assigned dollar values associated with the maximum impact of said risk and then assigned probabilities for the risk, which then suggested how much risk or contingency for the client to carry. Now I'll pass it over to Audrina. Thank you.
Thanks, good job, Dustin. Okay, before I get started, who here is excited about embodied carbon? Yay! Okay, cool. So it's really interesting, like this project, when we took a look at it after completion, we realized what was achieved. An existing building that was revitalized and brought back to life, where it needed so much work to bring it back to this level of quality. And we thought, how much embodied carbon does that save to actually do this instead of having to demolish it, ship it all the materials away, bring in brand new materials and rebuild it? So we thought we'd do a little study. So I'm just going to go through a little bit of nerding exercise. So, and what I think is really interesting is embodied carbon is going to be in our national building codes by 2030. So we want to get that literacy out there. We want to start to understand how and what we can build, how we can do it with the lowest impact possible. So this is just a little bit of an exercise that our team did to see what we could do. So I'm just making sure I got the right slide up here. So by utilizing an existing structure, we could actually save a ton of that framework. Not only does it save a ton of money, like it's about 30% for structural cost to actually rebuild a new building. We looked at the amount of embodied carbon we can save in reusing a long-term durable concrete frame. Then we also looked at the demolition of that building that we would have had to take down to replace. What does that save a project? How much material would we end up with? I did some research and validated with some folks, about $20 a square foot. So you can imagine that cost adds up. And that is even before you get started on a clean site. So what can we save initially? There will be some demolition, but we can be very careful with that. We started looking at the emissions of just removing the materials off of the site. Think of all the heavy loaded trucks, the weight of that on our roadways and our infrastructure, then we have to renew those roadways and infrastructure. So all of these things that we don't normally think about, we have impact on. So by changing how we look at projects, maybe we can find a way to really lower our emissions and meet our Canada 2050 goal. And so what if the materials stay in place? So this was fun, looking at the existing building and all the old existing drawings and some of the new. We leveraged as much of our bill of materials, our takeoffs, and manually measuring really old scan drawings, which is really fun. But we ended up looking at some quantifications. So the floor structures, columns, external concrete walls, and masonry reinforced walls on the drawings, and what we saw on site had this kind of amount. So I just allocated, like for the floor structures, we typically look at a 30 MPa concrete, type N because it's not exposed to air entrainment. Columns, I allocated about 40 MPa because it's a higher rise, but it's a very efficient structure. External concrete walls, these were really interesting. So by quantifying all of those, we have about 524 cubic meters, and these were like solid walls that we kept in place. And then there's some masonry reinforced walls that were still in the building on the drawings. So we maintained that and did a takeoff of the unit calculations on those. So a lot of metric transferring, a lot of math, and a lot of like making sure I got my calculations right by checking it on ChatGPT. So how this came about, we started looking at like, what can we measure? We can't measure everything because if we avoided something, it's so hard to get what you didn't do. What we do know about is the materials we can take off. So on the concrete and masonry, by reusing it, we avoided replacing it with 800,000 kilos of CO2 emissions. Now, as a metric, I tried to turn that into like a little bit of a breakdown on the right side if you really want to get into the data. But what I thought was really interesting to put it into relatable context, this avoided about 3,700 litres of diesel equivalency. So imagine not having to burn that much diesel, and that's what we saved just by reusing just the concrete portions alone. I didn't even calculate rebar, because that's a bit of a trickier one when it's harder to find historic information on. So we can only measure what we know or what we can quantify. So for us, understanding that this is about 170 trees grown for 10 years, that's the amount of carbon that we've avoided just in the concrete. Oh, thank you, ChatGPT. So the next thing we thought we could study was the envelope. Understanding that BIPV has an upfront carbon cost to it. We do have to manufacture materials, but the envelope needed replacement. It was falling apart, And so if we were going to do that, what does it take? So from measuring what we could identify these materials, the Mitrex Cladify. They have EPDs, and they have a lot of data around their product, which is super exciting. There's some sheathing involved. There was a liquid applied air vapor barrier, some insulation, so we use mineral wool, and some glazing systems included. So I calculated all of the takeoffs and quantified it against each of the industry average EPDs or product specific. So Matrix Cladify has their own released EPD. They did use a different methodology of calculation, but there is a letter that comes in that transfers it over to like GWP, which is global warming potential for those who are still learning about embodied carbon. It calculates the impact of CO2 to our atmosphere for 100 years. So that's the kind of level of quantification that we're talking about. So all in all, this adds up to about 200,000 kilos of CO2e. And to put that into perspective, if I breathe out, in and out, all day, it's about 0.7 of a kilo of breathing carbon dioxide emissions to the atmosphere. So you can imagine how many people will have to hold their breath to get 200,000. So for us, we wanted to say, okay, how does this work? With an active solar grid now put into the envelope and built in, we can start to look at like how much clean energy does that offset in terms of emissions. We're looking at like how does this trade off in terms of how much upfront carbon we need versus how much we can clean the grid. So on the top right, I've got the emissions intensity for the Alberta grid. It's about 540 grams of emissions, which is the fourth highest in Canada. The cleanest being Quebec, Manitoba, which is really awesome to see. Prairie's doing it. BC, Newfoundland and Labrador has pretty low as well, and Ontario has 30. I highlighted Ontario because that is where they manufactured the Matrix cladding. So manufacturing locations really matter to lower your embodied carbon because they're using clean energy to make those products. And when you get the slides, I've put some links up to how to find those emissions intensities. In addition to that, we're looking at upfront carbon. So in totaling all the upfront carbon for just the BIPV alone, I also looked at what it was to have it not solar generative. So it's about 50% less. So we're talking about a delta of what we would have had to do for cladding versus solarizing the cladding and the amount of clean energy that it generates. So I think on the study, it generated estimated 173.65 megawatt hours annually with some level of degradation and that calculation. So it was about 93.77 kilos of CO2e. And that's when I multiplied it by trading it off with the Alberta grid intensity. So we've actually avoided that by putting that much in every year. And so with the degradation of the clean energy, the savings, once you eliminate the upfront carbon, is huge. We're looking at 1.9 million kilos of avoided emissions. So in 25 years, so over the life cycle of just the solarization of this panel. And we're talking about now 734,000 litres of diesel avoided. Like that's the level of equivalence in terms of emissions. So really, when we talk about understanding what we do, we need to clean our energy grid. We need to really invest in that infrastructure that allows us to have a sustainable and resilient shared electricity grid. As we move towards electrification, as we move towards renewables, it's a pluralist mentality. I think it's a yes and. We do need fossil fuels to be able to build this equipment to allow us to transition off of it. It's not something that we have to be one or the other. I think it has to be something we work together and across all industries to achieve. So for us, we want to support actions like this. We want to do the hard stuff and find different ways of building. The total impact from updating this envelope, so I dissected the energy outputs. Thank you very much. That was really good. So by looking at the total reductions annually for each of these interventions from the ECMs, looking at the upfront carbon, when we deduct that, we still get a really great outcome. So annually, we avoid about 340,000 just on the envelope upgrade alone. In terms of litres of diesel. Like, I'm trying to use that as a way that you could imagine how much emissions that would have costed the planet. And then if we look at it over a 25-year impact, like we're talking about 8.5 million. And that's the life cycle of the envelope, if not more. It can continue to provide more. And with the comments we had earlier in Neil and Dustin's presentation, there's lower maintenance. You get more occupant comfort, so they're not likely to turn up the thermostat because they're not feeling drafts. All of these things, they sound expensive now, but over the life cycle of the 25 years, understanding the blend of OPEX and CAPEX is really critical. And I know traditionally these two are separate, but we need to start breaking down those barriers and really comparing the two. So that brings us to the end of the slides. I don't know if we're early, but hopefully there's a lot of questions. Thanks, everyone.
Okay, we have about 15 minutes for questions. I don't think we have a mic. Is that, no, so just use your loud voices. Go ahead. Yeah, lady there, yes.
Great presentation, everyone. Neil, could you speak a little bit to who your tenants are in this building now?
Yeah, for sure. So when we originally were planning the project, we were targeting students, so we're in close proximity to McEwen University. What's happened in reality is a little different. So the bulk of our new residents are young professionals, maybe they're new graduates, they're working downtown. We have a large population who work at the Royal Alps Hospital, which is walking distance. So it's not as student-centric as we planned, which is great for us. Our avenue as a whole, we target workforce housing residents. That means folks who are in the workforce, need an affordable place to stay, it's good value, in the right location. So I'd say on this project, we've nailed our demographic and get the people we want to vote.
Great, thanks.
Thank you. Thank you. So the question was about our financing and grants. We didn't use any grants on this, but for financing, we partnered with the Bank of Montreal. So they had just started a new product to support owners like us who want to do deep energy retrofits. The benefit of their project is they also provide a loan on the non-energy efficient work. So we can work with one lending partner. We get favorable terms on our energy efficient scope of work, lower interest rates, higher loan to value, and then we get a traditional construction loan on the rest of the scope. So no, we're not. Avenue Living is a mutual fund, so we looked deep into this because there's great benefit. The question was around ITC credits, and you have to be a true real estate investment trust to get it. We're technically a mutual fund, so our tax experts said we don't qualify, unfortunately. Yeah. Thanks.
Two questions. So the first one, you had some greenhouse gas emission reduction goals. Did you also have energy efficient goals to help guide you on how far you go down the deep energy retrofit? And then the second one, assuming you're reducing the utility cost, have you changed how you're renting to your tenants? Are you including utilities or not, or some? Have you changed how that happens?
Sure. Yeah. Great question. So you're asking about greenhouse gas goals versus energy efficient goals. Our vision for SunRise was to go, to the max in every case. So every type of building change or ECM change, we said let's go as deep as we can and as efficient as we can. The resulting impact was the 64% GHG reduction that was modeled. As we're leasing up, we're just starting to get into measurement and verification. So we're gonna see in the next year how we're performing based on the forecasted model. And sorry, what was the second question?
The second question is about how you're leasing the utilities, because now that if you improve the efficiency, your building's going to use less energy. If your tenants were paying for utilities, they get that benefit, you don't.
Right.
So are you changing how you?
We did make a significant change through this project on utility billing. So prior to the project, all utilities were included, including electricity. We had 1 meter for the whole building for power. One of the ECMs was to sub-meter the building, so we partnered with Metergy, and they have revenue grade ammeters that measure the power going into each suite, and then they have the administration behind it to do the billing. The benefit to us is we turn all of our residents into their own energy managers. Because they're paying for their heating and power now. They're not going to leave windows open and run the AC and things like that. So by creating 179 energy managers in our property, we're going to lower our consumption.
What do you do with the electrical energy? Do you use it internally, or do you sell it to the utilities, and how much do you generate?
Sure. Yeah, I can speak to the metering scenario. We have a interconnect agreement with EPCOR, and it's a two-way meter. So all the power we produce ends up going to the grid. We get a credit, and then everything the building consumes is on a separate bill. Then I'll let you speak to generation.
I was looking at the energy reports from the modelling on the solar, even including on the north side as well, because it's all solar activated. And because of the azimuth that we have on such northern environments, we actually do get exposure, and it actually does collect energy. So with all 4 facades, it was generating an approximate 173 megawatt hours annually, which is huge. And I think for us to understand that consumption, like over the life cycle of a building, it gives you also flexibility to build more electrification in the future. So a lot more flexibility that way.
Are you guys sub-metering it right now? Like, is it live?
It's live, yeah.
I'll just pull up some of that previous data. So this is a chart of what the predicted... Oh, it's not showing. Okay. Oh, that's weird. Tech support. Okay, I'll share it again. See if okay, well, have a look at the handouts later when we email it out. But a lot of the annual, oh gosh, my computer just died. Fun times. The actual annual cost savings measures. Oh, hey, that's my dog. Oh boy. I'm going to show it to you guys now. So hang on a sec. So this was the projected annual cost savings on the utilities. So I think there was definitely an incentive to make sure that, and this actually shows the solar PV. This version of the design allowed the largest amount of cost savings, second to the lighting upgrades. So in understanding that, with the payback periods that were approximated, these are the sorts of things that we look for. And with the next phase 2, phase 3, we've been looking at this across all 38 buildings, 18 properties. And this is where we're now in that decision-making process of really understanding, like, what's good for the building, what's good for return rates, what's the cost of construction per GHG reduction. So I think these are real key metrics that we're learning about and how to implement and how to sharpen the pencil. Get the best bang for your buck, utilize as much of this to upgrade your building where it's, with all the benefits of having additional low-cost capital. So does that answer the question? Oh my God, so many more people. Okay. Yeah.
1 or 2 more.
Okay.
Yeah, 4 minutes.
You want to pick?
Thank you. Couple. So quickly, the first one, Neil, the BMO product that you used for this, I'm assuming that flowed through the CIB, access to the CIB fund, correct? CIB funding. And I'm just curious, does BMO take a markup on that, or do you split the same competitive rate that you would get, and then BMO makes their money by wrapping up getting the additional financing for non-residents on top of just flowing through the CIB?
Right, so the question's about BMO's Deep Energy Retrofit Lending Program. So yeah, the pool of funds that supports our energy efficient scope of work, that did come from the Canadian Infrastructure Bank. So BMO has their own credit agreement with CIB, and then they carve out portions of it to redevelopers like ourselves. Where they make their their money. I think there's a small margin on the CIB portion, and then it's a traditional construction loan for the balance of the work. For this project, we're about 50-50. About half the scope was energy efficient related, and the other half was things like suite upgrades, common area upgrades that we were doing anyway. I think there was a question about the project cost. We're about 25 million. I forgot to answer that previously. So, and about half of that is energy efficient work.
The other one I had was you mentioned the scale and out of town, the smaller projects, the smaller buildings, and the out of town projects.
Yeah.
I just couldn't quite stack up the numbers. Tell us a little bit more about that. Like, what was it? Was it that you needed certain economies of scale? Was there certain fixed costs that go into these buildings regardless of their size, so they need to have a certain scale before you start getting value on those fixed costs?
For sure. So the question's about why we're focusing on larger markets as opposed to our smaller markets. Like, you know, we operate in Brooks, Yorkton, smaller cities. It really comes down to apartment valuations. In bigger markets, our per unit value of a apartment is higher. That affords us room on our balance sheet to invest in the energy retrofits. In smaller markets, there's just not enough benefit and room on balance sheet to make the investment. So we've steered ourselves to our bigger buildings and bigger markets.
Okay, that's time. If you had more questions, I encourage you to find our speakers later. But thank you all for coming. If you can join me in just thanking them and Audrina, Dustin, and Neil for their presentation.